recording now. All right, guys, we'll get started. So today what we're going to do is a revision session looking at paper 2. So we're going to look at some of the key topics from paper 2, and then we're going to look at an exam question and then answer it together live. So let's have a look. You've now done 50% of your GCSE in computer science. You did the paper 1 exam on Friday. We have the paper 2 exam on Thursday of this week. And paper 2 is made up of 4 chapters. So chapter 7, which is algorithm design and problem solving. Chapter 8, which is programming. Chapter 9, which is databases. And chapter 10, which is Boolean logic. So we're going to look at a variety of questions from these chapters. And then remember, the structure of this paper is, so all of it's relatively straightforward-ish in terms of the content. The only really tricky part is the 15 marker at the end. So the 15 marker, I'm not sure if we're going to have enough time to cover it in like great depth today. But if you guys are free, just when your schedule is, either we'll do another session tomorrow, either Monday, Tuesday, or Wednesday on just the 15 marker. That way we can just focus. But today, the plan for today, what we're going to look at is programming constructs. So there's like about 6 that we need to know. We're going to look at writing some pseudocode. We're going to look at the common question of programming errors, where you get some pseudocode or program code, and then you have to find 4 or 5 errors. Then we'll do a question on logic gates, some SQL, which is databases. I think all of databases is quite straightforward, but SQL is brand new to the spec this year. Then we're going to look at string functions, which features in all of the specimen papers. So I'm thinking that might come up, but I'm not sure. And then just a Q&A. So start off with constructs, and then we'll answer a question. So let's have a look at these questions first of all. So these are the constructs. There's variable, constants, arrays. Then there's 3 methods of iteration. Then there's 2 methods of selection. And then another construct is procedures and functions as well. So let's start off variable, constants, and arrays. I'm going to describe one, and then in the chat, you just have to write if it's a variable, constant, or array. Okay. So the first one, this is where we store in a program some item of data, a single item of data. But this item of data remains fixed while the program is running. So is that a variable, constant, or array? Yeah. Yeah, excellent, constant. All right, good. This data structure stores multiple items. So not just one item, multiple items that are related. Okay? An array, correct? Excellent, good. And then this data structure stores multiple items, and they can be 1-dimensional or 2-dimensional. Not a variable, an array, yes. Okay, so they can be 1D, 1-dimensional array, and they could be a 2-dimensional array. Good. This one stores it's a memory location in a program, stores a single item of data that can change in a program. So an example would be something like a score. Yep, excellent, variable. Good. So we know the difference between variable, constants, and arrays. Now, 3 methods of iteration. Another word for iteration is loop. The correct terminology is iteration. What are the 3 methods of iteration? 3 methods that we need to know. While is one, yeah. While, for, not if. So while, for, and is one more. Repeat until. Excellent. But look at this. So I'm just going to write this in the chat. Post condition is a repeat loop. Okay. So they might use that language. Precondition is a while loop. And then the final one is count control. Count control, which is a for loop. Okay. So they're the three different types of loops. When you're writing pseudocode, they might tell you to use a particular one of these, or they might allow you to decide. But when you're deciding, you have to decide which one is the best method to use. When we know the number of iterations, i.e. we want to repeat something a fixed number of times, 10 or 20 or 30, for example, we know that. What type of loop do we use? For, correct, yep. So for, or a count control, excellent. Or also known as a count control. That's when we know the number of times we want to repeat. Okay, now a conditional loop is based on a condition. So it keeps looping until a condition is met. But there's two, there's pre and post, okay? A post condition is, it repeats at least once, okay? And that's a repeat until loop. Where a precondition loop only repeats or only iterates or loops when the condition is met. And we're going to look at an exam question in a minute, and then we'll see what this looks like. So there's, only repeats if the condition is true. But with a repeat, right, the difference between a while and a repeat, they both are based on a condition. So it only repeats until the condition is true. However, the difference is a repeat will do it once, okay, and then check the condition at the end. That's why it's called a post condition. So it does a loop at least once. Where a while might not even enter the loop because the condition is checked at the beginning, it's pre. So it might not even go into the loop. So that's the difference between the two conditional loops. Okay. All right. Last question: procedures and functions. So we can have something like this procedure. It looks like this. I'll try it in the chat. The name of the procedure. I don't know. Print. Say procedure addition, and then it might look like that. And then we might have a function, also called addition. But there's a difference between these, a fundamental difference between a procedure and a function. Both are subprograms, or we can say examples of subroutines. But there's one difference between the two, between a procedure and a function. Anyone remember? Something about returning a value. Good, yeah, excellent, Mohammed. So yeah, excellent. Thank you, Fatima. So a function returns a value, and a procedure does not return a value. Let me see if I can find a quick example. Procedures and functions. Right, these are examples in Python. I'm just going to present. So this first example is in Python, okay? So this is, that def means it's a subroutine. This is a procedure called output name, and all it does is just prints your name. So it's a subprogram, and you can see it's indented. However, a function is the same. It's a subprogram, but it returns something at the end of this subroutine. So in this case, it's going to return the addition of these three numbers. Number 1, number 2, and number 3, and then it returns something called number 4 to whatever. So what happens is number calls a function called add with 5 parameters. So parameters are the values that we use, 5, 10, and 15. And then it does number 4, just adds the 3 together. So 15, 20, 30. And then it returns 30 to wherever. So number becomes 30, and then it prints 30. So the difference between a subroutine, a function and a procedure doesn't return anything. It just carries out the program, where a function has this line here, return, which returns something. All right.
Wouldn't we always want it to return something?
Not necessarily. Not necessarily. A function is more practical and useful. So you want it to return a value, but sometimes you just want it to carry out a task and not return anything. You just want it to carry out a task. So then we'd use a procedure. Okay, let's have a look at now some questions on constructs. So let me just present, and you guys can see it. So we'll do a topic and then a question. So all right, guys, can you see the question? Is it clear to you guys, the question, or is it too small?
Yeah, it's good.
Okay, all right. So let's look at some. So on the left, we have a description, and on the right, we have some statement. So we just need to match these up. So this one, it says a loop that will iterate at least once. Anyone want to have a guess? A loop that will repeat at least once. Repeat until, yeah, excellent. Good. So we just, there you go. Good. A conditional statement, I forgot to mention that actually in the presentation. So the 2 methods of selection. What are the 2 methods of selection again? Selection, so you make a decision in a program. There's 2. There's if and case. Excellent. So if and case of. Thank you, Mohammed. So let's have a look at this question here. A conditional statement to deal with many possible outcomes. So is it an if or a case that deals with many possible outcomes? Case. Excellent. Good. Most of you got that correct. Brilliant. Case. Now this one, a loop that will always iterate a set number of times, a fixed number of times. Good. 4. Yeah. Excellent. Because we need to, we use a count controlled loop or a for loop when we know how many times we want to repeat something. Now a conditional statement with different outcomes for true and false. So conditional statement with different outcomes for true and false. It's not a while loop, no, not a while loop. A while loop is a loop, okay, where this is a conditional statement. So if it's not case, then it must be if. Excellent. Good. There you go. Nice. So hopefully we'll get a few of these questions on Thursday somewhere where you match up. Were there any match up or fill in the gaps in paper 1? From the paper 1 on Friday, were there any matchups or no?
Yes, so there was one on different types of software.
Oh, brilliant. Okay, yeah. Good. How many marks was that, Mo?
I think it was about 4. So 4 blank spaces, and then we had to fill in 4 different words. Yeah.
Oh, not bad, not bad. All right, so I'm guessing they'll probably be the same. All right, let's have a look at this. Let me zoom in so you can see this question. So this is, I need to add some text. It says using a single loop, write an algorithm in pseudocode to output 50 names that have been stored in an array. So, the first thing we have to decide, when we're repeating something, there are 3 types of loops we can use. We can use a count controlled, a precondition, and we can also use a post condition. This one, we know it tells us there's 50, and it doesn't specify which one to use. It tells us output 50 names. So we know how many times that's going to repeat. So what type of loop do we use for that? A while loop. We could use a while loop and base it on a condition, but yeah, controlled loop would be better in this circumstance because we know it's a fixed number of iterations, so 50. So I can say 4, for example, 4 count, and then I'm going to write in pseudocode. That's the arrow 1 to 50 because it's 50 iterations, and then indented inside. Now look what it says: using a single loop, write an algorithm pseudocode to output 50 names that have been stored in an array. What command word do I use when I want to display something in pseudocode? Okay, print, Maya, is in program code. Print is in program code. So we use output. Yes, that's it. So if I'm writing in pseudocode, I could write, if I was writing it in, because it's a pseudocode, I have to say output, and then the name of the array. What's the name of this array in the question? What's the name of this array? If I just put the question back on. Yeah, name, excellent. So name, and then I'm going to use these square brackets, but I'm going to leave it empty for now. And then I'm going to say next, count. Okay, oops. And then in here, if I just do output name, that's going to print the whole array 50 times. But I want it to do each name, one name at a time. So what do I need to put in brackets here next to the name? Count, excellent. Thank you, Kumel. So I need to put the variable count. Would that work? Would that be okay? It's a problem. There's a problem with that though, Kumel. Look carefully. What's the problem? What's the issue? Not the end. Does this variable capital count exist? Does it exist? When I declared or used count, it was lowercase. So now it's referring to something that doesn't exist. So this is going to result in some sort of error. So I now need to do lowercase. Should be lower, exactly. So now look at this. For 3 marks, it says using a single loop, write an algorithm in pseudocode to output 50 names that have been stored in the array name. So we have this array called name. We've repeated this instruction 50 times, and it's going to output the first name, and then 2, and then 3rd, and then 4th, until it gets to all 50 names. So these are the types of questions that you expect with regards to, constructs, okay, or programming constructs. What I would say is you definitely need to know the difference between variable, constants, arrays, the 3 methods of iteration loops. So for, repeat, and while, or count controlled, post condition, and precondition. You need to know the difference and when to use each one. The 2 methods of selection, if and case, and then procedures and functions. If you have an understanding of this and you're able to write pseudocode for all of these, then you should be, I think you'll be fine in terms of constructs and pseudocode. Okay. All right. Let's move on now to the second topic. Yep.
The question that we just did, I thought that in the arrays we need to put the names. How does it work if we just put 1 to 50?
Sorry, repeat that again, please. Sorry, I didn't quite understand the question.
Like, I thought in an array we have to actually write out all the names. So how does it work when, like...
Okay, so we write out the names when we're creating or declaring the array. All the questions are saying to us, there is an array with 50 names called name. We don't need to write. I don't need to set it up like this. I don't need to say this. I don't need to do name, Judy, for example, Ali, and so on. There's no need for me to do that because the question's asking us to output the names, assuming this array already exists. You see? So behind this program or somewhere else, there's an array called name that has 50 names already stored. It wouldn't ask us to store 50 names. It'd take too long to write 50 names in an exam. but it's making an assumption it already exists. And all we're doing is we're saying output this array called name, and then the square brackets would be, so if I just show you an example here, if I say, I'll just do it with a few names, I'm not going to do all 50. So if I say Judy, Mo, Ali, Tom, for example. So what this will do is it will output name 1, because count is a variable counting from 1 to 50. Name 1, so it will output Judy, because that's the first name. Then it says next count. Count now becomes 2. Then it says output name 2. That's Mo. And then output name 3, Ali. And then output name 4, Tom, until it does all 50. But we don't need to write all 50 names, because it's already, it says that have been stored in the array called name. So it's already been stored. So we don't need to do that. Does that make sense, Judy?
Yeah, that makes sense.
All right.
Thank you.
All right, let's move on to the second question. This is quite a common question in paper 2. I'm hoping it comes up. I'd like to say it comes up every year, right? But then I thought von Neumann comes up every year. So it might not be the case, but it's good to be prepared for this. This is when you get some pseudocode question. You get some pseudocode, and the exam board will purposely include some errors. And your job is to read the pseudocode. You can test it with some, data, and then you're meant to find the errors. Normally, there's between 4 and 5 errors, and you're meant to correct the errors. So, when we're doing this question, you want to look for what we call logical errors, not syntax. We're not concerned with syntax. We're concerned about things that will affect the logic of the program, not, for example, they've spelled output wrong. Or something along those lines. In order to know how to correct the errors, and we're going to do one question now, you need to know the purpose. And what that means is you read the description at the beginning of the question. Then you can just trace the code. If you get stuck and you can't find any errors, so you just trace it with some numbers and see what happens, and that will help you identify the errors. So let's have a look at a question. Okay. All right, so this is the question. I think you should be able to see it yet. An algorithm has been written in pseudocode to input some numbers. It only outputs any numbers that are greater than or equal to 100. The number 999 is not output and stops the algorithm. So what should happen is I should be able to keep entering numbers, and then it will tell me if that number that I've entered is greater than or equal to 100. If I enter the number 999 in this algorithm, what will happen is the program ends. It stops the algorithm. So let's see if we can identify some errors. This is from the specimen paper. All right. Okay. All right. So can anyone spot any errors, any problems with this code? Maybe you've done this question before, but any errors in this code? Can you guys see the question, by the way? Shall I zoom in a bit? Yeah, any errors? Okay, so line 2 should say number instead of numbers. Excellent. Look at this. So if we count the numbers 1, 2, you input this thing called number, stored in a variable called number. But then the loop is checking for a variable called numbers, so S. So this will result in some logical error because this variable doesn't exist. So it's going to be looking at another variable. So yeah, so line 2, and then we can say line 2, we can say the variable should be number, not numbers, which is incorrect. Okay. All right. So that's the first error. Okay. Any other errors? Line 3 should be greater than or equal to, not just greater than. Excellent, Mo. So if you look at this, look, we have to read the description. it says it only outputs numbers that are greater than or equal to 100. But on line number 3, the if statement is checking if a number is more than 100. So if you put 100, it's not going to account for that. So on line 3, it should be more than and equals to 100 and not just more than 100. Okay, so you see that on line number 3, we should have in fact, I can correct it on here. I'm going to correct it on here as well. It should be, you could do it either way actually in pseudocode. There's no set syntax. If number is more than and equal to 100, and here we're going to delete the S. So we fixed it. Okay, 2 more errors. 2 more errors. Yeah, Maya?
Sir, I have a question. You know how it says you say where the error is and then you say the correction?
Yeah.
Do you have to explain what the error is, or could you or do you have to like rewrite the right thing?
You rewrite, because the question, it depends on the question. Sometimes it says identify the 4 errors in the pseudocode and suggest corrections. So identify would be, you'd say the line number or the actual line of code if there's no line numbers, and then the correction, which is the correct piece of code. Sometimes it might ask you, explain why this pseudocode doesn't work correctly. So it depends. In this question, we just have to identify the line and then suggest a correction.
Okay,
So
thank you.
Right correction. All right, cool. All right, can anyone see any other errors? Don't know if you guys can see it well. There's a problem. Look at this. Let's trace this, right? How many? Yeah. Mohammed.
So, so the algorithm says that 999 shouldn't be output, right?
Yes. Yeah.
So thing is, there's still an output at the end.
Yes.
So we need to remove that, don't we, to make sure that the 999 doesn't get printed.
Correct.
Outputted, sorry.
Correct. Here, look, we've outputted number. So whenever a number is more than 100, 999 ends the algorithm, but then it'll output 999. But then, like Mo's identified, the number 999 is not output. So this line we just delete and remove. So we could say, what line was that? So 1, 2, 3, 4, 5, 6, 7, 8. So line 8, the output is not required. We can remove that line of code. All right. Now there's one more error. How many, if I was to trace this, how many times will it let me input a number? How many times will it let me input? Yeah, Judy.
So I wanted to ask a question.
Yeah.
For the error that you just said, I didn't really get why we should remove that last part.
Okay. Because, all right, so look at this sentence here. It says the number 999 is not output and stops the algorithm, right? So
but didn't it say not equal to 99?
Yeah. So if I left that, if I put it back, if I write output at the end, number, if I did that, if I leave it like that, right? Let's trace it. I input 999. That stops the algorithm. Okay, that stops the algorithm, and then at the end of the algorithm, it outputs 999. You see what I mean? Let me trace it again. If I input, say, 200, I input the number 200. If number is more than 200, then it is. Then output number, it outputs 200. That's correct, because we want output 200. But if I now do the same, if I test it with 999, follow me now. I input 999. It says while number does not equal 999, do all of this. So it doesn't go in. It is 999. So it doesn't do this bit of code, but then it outputs 999 because that's not inside the loop. Do you see it?
Yeah, no, I understand.
So then, but it says it's not output and stops, but that line is going to output 999. All right.
Okay.
There's one last error. This one should keep repeating until I enter what number? Until what number stops the algorithm? What number stops the algorithm? There should be another input number inside the loop. Good. 999 stops the algorithm, right? But this line here is only going to, because it's not inside the loop input number, because it's not inside the loop, it should be, it's only going to let me do it once. You see what I mean? If I entered 100, it'll only do it once. 200 once, 300 once. So that means we need to input another line that says input number within the loop. You see, within the loop. So now I enter 100, I can enter 200, 300, 400, 700, 800, until I get 999. But if I delete this line, if I didn't have that line, then it's only going to let me input once, but not again. But if I put that line again, input number within the loop, it's going to keep letting me input a number, and it's going to keep checking until I enter 999, which stops the algorithm. So the last correction is, so if I just put the correction here, input number should be inside the loop. Okay, so we should have that. So it repeats it until it meets this condition where it's not 999. All right, now look at this. It says for 2 marks, write a pseudocode statement to change the corrected algorithm to output all the numbers between 100 and 200. This algorithm is saying greater than or equal to 100. So we need to somehow, I'm going to copy this line here. We need to change it so that now it has another condition. So I have to add something here to check that it's between 100 and 200 inclusive. So what can I add? This is only checking if it's more than 100. So how do I add another condition to this? Shall I use the word and? And then the next condition, and number is less than or equal to 200. Can you see what that's doing now? So now it says write to the corrected algorithm, assuming we've made all of these corrections. And then it's saying now, instead of just checking it's more than 100, we want to check if it's between 100 and 200. So this is saying if the number is more than 100 and less than 200, so that's checking if it's inclusive, between those two numbers, and then it'll do something. All right. Did that make sense at all, guys? Any questions about that topic? Yes, if it's inclusive, then equal. We use the equal, Sharif, yeah. So if it says inclusive, use the equal. All right. All right, I'm just going to save that. We'll move on to the next topic now. So the next topic is logic gates. Okay. So let me just present my screen. So logic gates. All right. So this one you could just write your response in the chat. So logic gates previously, it was part of paper 1. This is the first year where it's part of paper 2. So I'm anticipating there will be a question on logic gates. With logic gates, what we need to know is the names of the gates, which is these gates, the 6 gates that I have here. Then we need to be able to construct a diagram based on a statement, which we're going to look at. And we should be able to complete a truth table as well. So we're going to look at all of them now. All right, first, the one in the top left. What is the name of that logic gate? Top left. And excellent, good. Oops. And then, so that's an AND gate. And then the second one. Or, correct, yep. And then the third one. Third one across. So top right-hand corner. Yep, not. And then now starting from the bottom row. So these are the three basic gates, and, or, and not. And then bottom left. Yep, NAND. And then the bottom row in the middle. XOR, yep, or XOR. And then finally, we have a NOR gate. Yeah, correct. Good stuff. So they're the 6 gates. Let's have a look now. This one, if anyone wants to volunteer, you could just say the answer out loud. So we've got the AND gate. Which of these descriptions on the right matches AND gate? Anyone? If you just want to say it out loud.
Second last.
Second last. If A and B are on, then the output is on. Correct. Or, yeah, correct. Thank you. If A and B are on, then the output is on. So it requires A and B to be true in order for Q to be true. Any other variation is false. All right, second one is an OR gate.
Is it the first one?
First one, if either or both A or B. Yeah, correct. Yeah, nice. So it just requires now, different to an AND gate, this just requires one of them to be on, to be true. Okay, the third one.
It's the second one.
Second one produces an output that is the opposite. Yeah, good. The inverse. You'll notice all of the gates have 2 inputs. This is the only one with 1 input. And the reason why that is what a NOT gate does is it inverses. So if this is on, this is off. If this is off, this is on. So it's the opposite. All right, good. Next one is a NAND. The NAND is the opposite of which gate?
And
Correct.
Gate.
Good. An AND gate is combining a NOT and an AND together. So it's a way of simplifying when you have a NOT and an AND together. So it's the opposite of an AND gate. So which description do we think matches that?
the third.
Third,
No.
yeah, correct. Yeah,
Yeah.
the third one. Yeah, because look, if A is on and B is on, and it's in a normal AND gate, then the output would be on. But with a NAND, it'd be the opposite. Okay, good. 2 more now. We have XOR or XOR.
XOR is the opposite of OR.
XOR is not, no, XOR is not the opposite. The other one, NOR, is the opposite of OR. NOR is the opposite of OR. XOR is something else. It's about being unique. In order for the output to be on, A and B have to be what? Can they be the same?
So it has to be different.
It has to be different, correct. With the XOR, they have to be different. So the logic gate that produces an on when the number of inputs is an odd number. So they have to be different to each other. They can be 0 and 1 or 1 and 0, but they have to be different. If they're the same, then it results in the output being off. So there's one more, which is NOR, which is the opposite of an OR gate. All right, let's look at a question now and see what this looks like. So logic gates. Okay, give me a second. What I'm going to do is I can't draw the actual gates. It's a bit tedious. So I'm just going to, give me a minute, sorry. Okay. All right. So let's have a look at this. Okay. Let me just present my screen. All right. So now, because the question is here, right? But I can't, it's a bit tedious drawing the gates. Okay. So it says, consider this logic expression. So X equals A and B, or B and not C. Okay. So I'm just going to look at this, the simulator here. Should be able to see. So this is A, B, and C, and then this is the light bulb is X. So if I'll just answer it just to make it easy. So this is A and B. So this is A and B. So I just need to find an AND gate. Okay, that's A and B. Okay, that's the first part of the circuit. And then it says OR, and then I'm going to concentrate on this B and not C. So C has a NOT gate, which is an inverse. Okay. And then it's connected to B with an AND gate. So now if I find the AND gate, okay, and it's connected to B like that. And then the two circuits or sub-circuits are connected together. If I go back to this, using an OR gate, okay? So using an OR gate. And then that's what this circuit looks like when you draw it here in the exam. And then look at this. We can often tell that we're right because we can self kind of identify. How many marks is this question? Can you guys see it? 4 marks, right? And how many gates have I used in my diagram?
4.
4. So I can almost see that I'm along the right track, so correct, because normally the way it works in the exam is 1 mark per gate. So I've got, not always the case, but that's a good way of telling. So I've got 4 gates, and I can tell that I've got this, I've got up to 4 marks. So now what normally happens is, sorry, I'm going to try and see if I can get the diagram across here. So let me just edit this diagram. Edit. Give me a second, guys. Sorry, I'm going to try and. There you go. Okay. So now I've got the diagram. I would have drawn it normally. All right. So normally this 4 marks, this leads on to some truth table from this expression. It's a bit tricky. I want to try and show you a method. Let me just this is A, B, C. A, B, C. D. C is over here. E. Oh no, what am I doing? D. This is E. D, E, and then F, okay? So that's F, okay. So this is A, B, and C, which has been done for us in the truth table. D is going to be A and B. E is going to be the inverse of C, whatever's in the column C. And then F is going to be B and E. Do you guys remember this method that I'm using now? Does that ring a bell with anyone? Do you remember this method of using the?
Yeah.
All right. Okay, so that method's a nice, how can I put it, an easier way of working out the truth table. So then I could break it down. So I could have D here. I could have E here. That's meant to be an E, sorry. And I could have F here. So it's just difficult doing it with the mouse. Okay, so that's F. And then I would just, so now, if I just show you this, if you just trace it here, so D would be A and B. So we look at A, column A and B. What would be the first one, 1 or 0?
0.
0. Okay, I'm just going to put a dot for 0, okay? Next one.
0.
0. Good, because I'll just go through it. 0. 0. 0. And then 1, and then 1. Okay, on the last two columns, because A and B is 1. So D, we've done now. We've broken it down. We've done that subsection of the circuit. You do that for each. So D, E, and F. And then eventually, X is made up of which two columns are we looking at for X?
D and F.
D and F, yeah, D and F. So if you use that method, sorry, it's a bit difficult trying to do the method by on the PDF. But if you use that method, it's a nice, easy way of foolproofing your truth table. Okay? All right. Logic gates. Any questions, guys, about logic gates?
Sir, can you just do one example of that one where they give you a truth table and then you make the logic gate for it?
Okay.
Yeah.
Sorry, when they give you what? Sorry?
The truth table and then you have to construct the logic gate.
Okay. All right. Let me find an
I think the
example.
same question you gave us on the paper 2 revision we had.
Correct. Give me a minute. I'll just try and find an example. I think there's only that example, the one in the paper. But let me see if I can find one quickly. Okay, give me a minute. Yeah. I think the only example is the one from that we did together. But let's have a look. I'll just show you that now. Okay. Yeah, this is the only example, okay? But let's have a look. All right. Am I presenting? No. All right. So look, can you see my screen?
Yeah.
All right. So this is the only actual example. And this is probably as hard as, so sometimes they'll give you a truth table and they'll say from this truth table, draw a logic circuit. It's a bit tricky, but the way you do this is we got the truth table. We turn this into a logic statement, okay? And then from the logic statement, we can construct statement. We can construct a circuit. Okay, so that's what we're going to do. So now if you have a look, it'll only have 1 or 2 where X is equal to 1. And we need to take those lines. So if I just zoom in a bit, how would I describe this line here with 1? What does it require?
A and B.
So A and, no, but B is false. So it should be
Wait, sorry,
inverse.
so A, not B,
Yeah, so it would be and what else? So
and
it'd be,
C.
okay, yeah. So we could say it would be, so X equals, we could say A and not B and not C. So that's describing that line, right? Okay. All right. Now, how would I describe the final line? How would we describe that? How would we describe that?
But sir, how do we know that we should use the AND gate?
Because it's saying, in order for this to be 1 has A is on, and B and C are off. So it's a combination. So we're saying A. If we said or, it would mean either B or A, but it's on the same line. So it means this whole statement has to be true. So it's A and not B and not C is describing this line. All we're doing now is we're just describing that line. So A and not B and not C. So we use and because it's all on the same, it's on the same line. Because it's saying A has to
Oh,
be true, B has to be true, C has to be. So how would we describe the last one? The last line, Judy? What would you say?
Would you say 1 and 1 and 1?
Yeah, it's 1 and 1 and 1, but use the letters.
Not
so,
A and.
Why not? Not is referring to when it's 0 in a column. They're all 1. The last column is all 1. So if it's all 1, it's going to be A and B and C. So this one is describing the last. In order for X to be 1, A has to be on, and B has to be on, and C has to be on. Did you see how I derived that?
Yeah.
Where this one is saying A has to be on, and not means it's not on, and B is not on, and C is not on. So this first line here is describing that line there. This line here is describing the last line. Is there any other descriptions that we need to write?
Needs to be an or in the middle.
Correct. There's going to be an or in the middle, but there's no other. X is 0 for every other one. We're only concerned with X is 1. So it's in the middle of this statement. It's going to be an or because it's saying in order for X to be on, it can either be that line or it can be that line. Yeah. And now once we've derived the logic statement, now we've got the statement. Now we should be able to construct a circuit or a diagram that represents this statement. So the method for this is, I'll just explain the method. You look at the truth table. From the truth table, you derive a logic statement by looking at where it has 1 in the columns. And then when you have your logic statement, then you construct your circuit from that statement. Okay. There's only, Julie, you never know if it comes up on in Thursday's exam, but there's only actually, one question, which is the specimen. So no past papers ever had that question before. If it does come up, just use that method, okay?
Okay. But just one last thing.
Yeah, go, Julie.
Do we ever have to write down they give us the logic gate, but we have to construct the A and B and
Yeah, that's common. That's a very common question. That one you just have to look at the diagram and describe the diagram. You say A and B are connected together using an OR gate, so it'd be A or B. That would be the first part. So that one's quite a common question as well. Yeah, go on, Sharif.
Is ever the case with the question we just did where it's not and not like different gates?
No, it'll only, because it says in the question, do not simplify. So you only use and, or, and not. They're the only options.
Yeah.
Because in that question it says, and in that type of question it says, do not simplify. And simplify would be using a NAND or a NOR, because they're combining 2 gates together.
Yeah.
All right. Okay. So guys, we're going to go over a little bit. But we'll do this because we've got, I think, 2 topics left. SQL, which is new this year, and also string functions. Okay. So let's have a look at this quickly. SQL, when I looked at the questions, it normally consists of 2 parts. So they give you a table that looks like this. You can see a table. And then it asks you about how many fields are there? How many records are there? Which one is the primary key? They're normally 1-mark responses. And then it leads on to an SQL question. Okay. So let's have a look at this. Look at this table. How many fields are there? How many fields? Just write a message in the chat. Count the number of fields. Yes, 7. Good, excellent. So 7, these headings here, first name, last name, age, phone number, nationality, house, ID. So each column of data grouped together is a field. How many records are there in this database? Sorry?
13.
13. Let me count. 1. So it's each row is a record. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Correct. So there's 13 records. So fields are the columns this way. Records are the rows. Excellent. Which field then is the primary key and why?
ID,
Good. Why ID, Judy?
because each number is different for each person.
Good. Each number is different for each person. And what in a description, what do they normally use in the mark scheme? A word beginning with U.
Unique number.
Excellent. So
Unique
each-
identifier.
Good. Unique identifier. Excellent. So that's normally the first
Wait,
three
sir,
questions.
can we say unique? Because from what I heard from like videos and stuff,
Yeah, go on.
you can't say unique identifier, you lose the mark. You have to say unique identifier for each record.
Yes. Yeah, no, unique identifier is not sufficient because that's not making it different. It could be a unique identifier, but you have to say each record because that's what makes each record different. We could have, for example, 2 Angelo Westerns from the UK, but their ID number will be making each record unique. That's why it's the primary key. Okay?
Yeah.
All right, nice. Now let's look at this. You know, SQL, I think will come up because it's brand new on the specification. So select, from, and where. So it gives you, we're going to do a question in a minute together. It gives you a question. Select is normally, so if I just put this up, I wanted to, let me just write this down here so you can see it. I want to to return all of the records from the UK and only display their first name and last name. All right. So now we need to add some things in here. Okay. So the first one is select is the fields that I want to display. What fields do I want to display?
First and last name.
Good. So first, comma, last name. Okay. Make this a bit smaller so it fits on one line. So yeah. So the select is only identifying the fields that I want to return. From is the name of the table. What's this
Student
table
info.
called? You guys see it?
Student info.
Good. Students info. And it'll give you in the question the name, students info. All right, good. Where is now the criteria that, so what's the criteria?
Nationality.
Good. Nationality is what?
UK.
Equals, good, UK. And that will return from this table the first and last name of everyone where their nationality is the UK. Order by can be one of two things. It can be ascending, or what's the other one?
Descending.
Descending. So ascending means from A to Z, descending means Z to A. So in the question, it will specify, it'll say do it in ascending order or descending. That will be the fourth column. Maybe there isn't, like the question we're going to do now, it only. Let's see what an example of this question looks like. Okay. Okay. So SQL, this is the database, a database table, 2018 movie, short for movie, is used to keep a record of movie details. State the number of records in the database table. So I don't know, you probably can't see all of it, right? But if what would I have to count? I'd have to count the number of rows or columns for records.
Rows.
Rows, yeah. For record, I count the number of rows. So now when I counted, if I just edit, if it lets me edit this, yeah. Yeah. So now if I just add some text here, when I counted, there were 20 records. That's the number of items in this database, rows. All right. Then it says, give the name of the field that would be used for the primary key? What name? What would it be?
No, sorry, cat. Wait,
Good.
the cat number.
Cat number, yeah. So if I go here, it'd be cat num. And why would it be that? Why would it be this field here?
Do we say that each record has a unique identifier?
Good. We say because each record has a unique identifier. Okay. And I've mentioned unique and I've mentioned record. All right. If we were to count how many fields does this database have? It's not a question in here, but how many fields does it have? Anyone?
Is it 7?
7, yeah. 1, 2, 3, 4, 5, 6, 7. So they're the category identifiers. Cat num or number, title, genre 1, genre 2, Blu-ray, DVD, streaming. All right, nice. Now, let's have a look at a second question. Do you know this one? It says complete the table to identify the most appropriate data type for each field based on the data shown in the database table. This is a little bit different, right, to when we're programming. Programming, so if I just show you this, the data types have a different name. Okay, when in programming, we call them string, integer, Boolean, and any other data type. Okay, but you know when we're dealing with databases, the names of the data types are different. It's either text, number, or Boolean. Okay, you see that? So text would be a string, number would be an integer, and then Boolean is the same. So look at cat num. Let's have a look back at this. Cat num contains both numbers and letters. So what data type would that be? Anyone?
Is it text?
Say that again.
Text.
Text, yeah. Text. So it'd be text because it contains both. We can't use a number, even though it's mostly numbers, predominantly numbers. There's a letter M. All right. Title. What would title be?
Text.
Text as well, yeah. Correct, yeah. What would genre be?
Text.
Text as well, yeah. Genre 1 would be also text. Okay. Streaming, what would that be?
Boolean.
Boolean, yes. Yes or no, one of two values. Okay. So either true or false, or yes or no. So that would be Boolean. Just bear that in mind. When you're programming, so the rest of the paper, you refer to the data types of string, integer, Boolean. But in just the database question, the data type is text, number, and Boolean also. All right. Now look at this. Complete the structured query SQL. We're missing some things. There's gaps. To return the category, number, and title for all the comedy movies. Okay. What keywords are missing from here, first of all?
From.
From, yeah. Okay, so it's from. From, okay, is missing from there, okay. And this guy's been hiding. So I'm just gonna read it. That was your head of year. All right. So you know this one, 2018 MOV. What is that referring to?
The name of the database.
Good. The name of the database table, which is that. All right. Excellent. So we're getting it from there. And then it says return comedy movies. So where genre equals?
Comedy movies. Comedy.
Yeah. Let's see what the column says. What does it have in the column?
So we just put comedy in quotations.
Good. Yeah. Excellent. So we do. We just say comedy. All right. Okay. Try and make this bigger.
Do we
So
lose
comma.
marks if, for example, we didn't capitalize the C?
To be honest, it should be exactly how it is in the table. Just be safe. Go back to the table and exactly how it looks and spelled and the case that they've used, use it exactly the same.
Yeah.
All right. Did that make sense in the terms of the SQL?
Yeah.
Bear this in mind, guys. This is brand new to the specification. So I think if there is a database question, which is probably going to be very likely, there will be an SQL question. Okay. All right, guys. One last topic now before we wrap up. I know we're gone 10 minutes over. We just got one last topic, and the last topic is
Okay,
all
so are we
about.
not going to do the 15-mark question?
No, we're going to organize now another time to do it because I've got an ECA now in 10 minutes. And the 15-mark question is massive. So I need to know when you guys don't have an exam, and then we can do another session like this, okay?
Yeah.
All right. Okay, actually, sorry. Let's have a look at this question before we one last SQL question. I managed to find one more. Let's have a look at this one. So we've got this table. How many fields are there in this database? Sorry, you can't see it yet. It's just loading. How many fields are there?
5.
Mm-hmm. Correct, 5, yeah. How many records are there?
8.
8, correct, yeah. Which one is the primary key?
Show number.
Show number because it's unique. Identifier for each record. For the show number, remember we can use different types of validation. So validation could be a range check, type check, presence check, anyone format check. You see those in the comments? If I had to do a what method of validation would I use for the show number field, that column? What method of which one of these would I have to do? Which method?
What's the question?
So the question is, so you know this column here, show number, this field, there's a method of validation that I can add, okay? Or I should add validation. So the methods of validation I've given you are range, type,
check,
presence, and format. Which one can I use? Which one should I use, or which one can I use?
type.
Type, yeah, good. Why type? By looking at it, what can we tell? What does it have to be?
Has to be unique.
No, it doesn't have to be unique. Type means,
Oh, yeah.
yeah,
Text.
it's actually not. We can use a type check, but there's a better one than type.
Format.
Format, yes, it has to be in a particular format check, because if you look at it, it's 2 letters followed by 3 numbers for all of them, right? So the format has to be 2 letters followed by 3 numbers, and that would be the method of validation. You know, show number is a primary key, right? Or unique field. Can I leave it empty?
No.
No, because that's what uniquely identifies. So what type of check is that then when you can't leave it empty?
Presence.
Presence check, exactly. So presence check. I think I've spelled presence wrong. Let me just correct the spelling.
Sir, would they ask us that question?
Yes, it's possible. This question is actually from a specimen.
What if there were 2, like now?
Then it normally says, this question said identify one method of validation. So you could either say format check or presence, and you'd get a mark for each one. And then you'd get another mark for explaining why. So presence, because we'd say this is a key field or unique field, which cannot be left empty, which is a presence check. Or we could say format check, because show number, we can see it's in 2 letters followed by 3 numbers, which is a fixed format. Okay. All right. Can you guys see this bit of SQL? You see this? All right. This bit of SQL, if I applied it to this table, try it. What would it return? What results would it return? The table, by the way, is called performance. What would it return?
It would return SN032.
SN0. No. Look what it's selecting. What is it selecting?
I'll return nothing.
No, it will return something. Of course, it's going to return something. Look at the select. Look at the first clause, select. It has date and title. So whatever criteria is met, it's going to return the date and then the title, right?
Yeah.
Yeah. Go on, Mohammed.
Will it
Yes,
have
so
Sorry, I don't know who that was. Go on, Mo. Sorry.
yeah, so sir,
Yeah.
first of all, it takes date and title,
Yep.
and we're looking for not sold out. So that means in the sold out column has to be no,
Yes.
and type has to be jazz as well.
Good.
So I think that only goes for one, and
Yeah.
that would be the acoustic evening, 3rd of November.
Good. In what order, though, Mo? In what order?
So it says date first, then title,
Yeah.
right?
Correct. Yep.
Yeah, so we do that.
All right. So 03 November, and then it will return acoustic evening. Okay. Let me see how we've derived that. Okay. It will return if we run this query 03 November acoustic evening. Look at the criteria. It says where not sold out. So not means it has to have no in the column. So how many have no in the column? 1, 2, 3, 4, right? And the type has to be jazz. For the first one where it says no, is the type jazz? No, it's drama, right? Then the next one, it is jazz. So it'll be that one. This one is comedy. This one is comedy. So the only one it will return is acoustic evening and 3rd of November. But if we go back to the select, which field comes first? Date, right? So it'd be 3rd of November in that order, acoustic evening. This is this line here with the show number SN113 is the only record which meets this criteria. Did that make sense, guys?
Yeah.
Okay. All right. So that's another type of style of question for SQL. All right. Last topic, guys. I'll do this one very quickly. String functions. So string functions, there's 4: length, substring, upper, and lower. You know this thing X in brackets and X, Y, and Z. What are they? What's the name of that in programming? Beginning with
Variable,
P.
procedure.
Not variable.
Procedure.
Not procedure. Procedure uses it. Parameter.
Parameters.
Excellent. Parameters. Excellent, Fatima. Parameters. Thank you, Sharif. So parameters. So length of X, we'll just find the length of whatever X is. Okay. All right. So if I said, for example, let me give you. Oh, sorry. Can you guys see my screen? Oh, you can. Okay. If I said X is equal to Mr. Salah, like that, and I applied length of X, what would be the length of this string?
8.
8 here. 2 plus the space 3, 4, 5, 6, 7, 8 characters. So length would become 8. Substring now, if I said X is that, okay? If I did substring X, comma, 1, comma, 2, 1, okay, so X is the string, which is Mr. Salah. 1 would be the position, starting position, which is M, and the last parameter, or Z in this case, or 2, would be how many numbers we would. So what would that evaluate to?
Mr.
Mr. Exactly, just Mr. Right? All right, let's try a question now. We've got this X and then a string that stores the word computing revision. Evaluate to length X. There's a space, by the way.
17.
Say that again.
17.
17. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Plus the space. 11, 12, 13,
18.
14, 15, 16,
18.
17.
Yeah,
18,
not
right?
17. Not
18. All right, 18. All right, so it evaluates to 18. Now look at this. I want to get, it says, of X, which is computing revision, go to the 11th character and take 8 characters. What would that evaluate to? What would that evaluate to?
Sir, would it start from N and then it goes on?
Let's have a look. You have so the first number is where it starts. So where's the 11th character?
Oh, so it's
1,
revision.
2, 3, 4, 5, 6, 7, 8, 9, 10 is
Oh,
the
I'm
space. 11 is R.
Wait,
And
so
from
you're
R,
gonna
how
be
many characters?
revision.
Revision, yeah,
That's what I
excellent.
said. Yeah, what I said.
Yes, thank you, Sharif. So revision, right? It'd be the word revision. So we've taken, this is a complete string. We've taken only part of the string. All right, good. Now, what will this evaluate to? Lower of P. What's P?
P is so just in lowercase
What in lowercase?
computing.
No, it's
No.
revision. It's revision. It's
Revision.
revision.
Yeah,
It's only revision.
Yeah, chief.
yeah, revision. Because remember, if it said X, it would be of this string. It's saying P, which is of this string revision. So lower of
Yeah,
revision.
so it is.
Cool. All right, let's just do a quick question and then we are done, guys. Last question. String functions. Someone's got their hand up. Yeah, Mo.
Yes, so I remember when we did this in class, right?
Yeah.
I remember we did like a few functions where it would like write the string in backwards and stuff like that.
Yes.
Do we need to know that for the exam or just these
No.
four?
No. So that was extra because we did that in Python.
Right,
But you got a great memory. In our specification, there's only 4 string functions. That would be length, substring, upper, and lower. That's it. 4 of
Right.
them.
Right. Thank you, sir.
All right. Okay, let's have a look. Let me just present my screen. Last question, guys, and we are done. I know I've done a lot of talking. Okay, who's got their hand up? Someone got their hand up. Judy.
Sir, when are we gonna revise the last question, the 15 marker?
We need to arrange that now. Now before we end, because I know you guys got exams, so I need to find a time when you don't have exams. And I've got a lot of frees anyway. And then we'll do that revision session. Yeah. Okay. So we'll do that after this question. All right, guys. Let's answer this question. The variables x, y, and z are used to store data in a program. X
Wait,
stores
okay.
a string. Sorry.
My bad to interrupt, but can we have the lesson prior to the test on Thursday? So like,
Of course, we're not going to do it after the test.
no, yeah, of course, no,
Yeah.
like
yeah.
same day. Like we all
On the
come
day?
early. We all come early to school.
No, I don't agree with that.
No,
No, I
Sharif,
think
that's not
What
possible.
other day
Yes,
we have
I'd rather
business?
do it before.
No.
No, we'll discuss it afterwards. Let's do this question first, guys. We'll discuss it afterwards. All right, so look at this. X stores a string. Y stores the position in the string. Z stores the number of characters in the string. So we need to declare these 3. So it says write pseudocode statement to declare the variables X, Y, and Z. So remember to declare, we use the keyword like this, declare. And then what's the name of the first variable?
X
X, good. And what is the data type of X?
string.
String, excellent. So that's the first one. Then we declare Y. We'll do the integer, yeah. Stores a position in the string, e.g. 2, which is a number. Correct. And then the last one, declare
Integer as well.
the Z, which is integer. So this for 3 marks, declarations, okay? Then it says the function, the function length X finds the length of the string X. We know that. Substring, so this is explaining what length and substring do. Write a pseudocode statement to store the string program in is fun in X. Find the length of the string and output it. Extract the word fun from the string. So let's do a step at a time. So the first thing we need to do, is we need to store the string program in is fun in a variable called X. So X, what does this arrow mean?
Equal to.
Equals, yeah, we're assigning. What do I have to write now in quotation marks?
Programming is fun.
Programming is fun, okay? And let me just, sorry guys, give me a minute. Let me just make this bigger. Programming is fun, okay. Now we've done the first one, store the string, programming fun is X, we've done that. Find the length of the string and output it. So what do I do? Output, and what string function do I use?
Length.
Say that again?
Length.
Length, good. Of what?
X.
of X.
Yes. So now I've done the second bullet point. Find the length of the string and output it. Now it says extract the word fun from the string and output it. So I need a
Isn't
new
it X23, something like that?
1 second. Let's have a look. So first of all, let's make two new variables, y and z. Okay, because they're going to store. Remember, we have y and z here. We've done x. We want y and z. So if I was to get the word fun, what position is that? Because y is the
3-3.
position. Say that again.
3-3.
No, not 3. You have to count all the way.
Programming is fun.
Yeah.
No? Yeah.
P is 1. R is 2. O is 3.
Oh,
Yeah. And there's spaces as well.
$15, not 16.
Let's have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, space 12, 13, 14, space 15. So F is going to be 16.
15.
Yeah, 6 because it's the. Okay, now Z is the number of characters long. So we're trying to find fun. How many characters is that then?
3.
3, yep. 3 characters. So now when I output, because this is saying extract the word fun from string and output it, I'm going to output, what is the name of this function that I'm using?
Length.
No, length is finding the length.
Substring.
Substring, yeah. Substring. And then now, 3 variables have 3 parameters going here. What are they?
X, Y, and Z.
X, good, Y, and Z. There's the pseudocode for 6 marks. Look at that, easy. So X is programming is fun. Y is the 16, which is the starting character. Z is the number of characters. So it goes to the 16th character and takes 3 characters. You got that?
Sir,
Mm-hmm.
whenever using string manipulation, is it always like a substring?
Correct. It's either length, which is the number of characters, or it's substring, which has 3 things. The actual string, and then the starting position, which is Y, and then how many characters we take from the starting position. Okay. So, okay, let's try another one. If I wanted to, I'm going to extend this. We've answered this question. If I wanted to output the word is, okay, what would Y now have to become? What does Y become?
13.
Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, 13. And what does Z become?
2.
2, yes, 2 characters. So now, if I do output, substring, and then it's the same. X, Y, Z. Now that would extract the word is. All right? Okay, guys. Okay, let's have a look now. Let me just give me a second. I'm just going to